Good morning, everyone. Lars here. Special morning time edition of the Python videos. I wanted to get this done, and I know I'm going to have a busy day, so I got up a little early, and I shot in here, and we're going to real quick do the Euler video. And tonight I'll release the assignments, and then later in the week you'll get a video with me doing my own little homework assignment. But if you recall, and I think I brought it up, I did. In class, the second class that we had, we looked at Project Euler number 6. And to refresh your memory, Project Euler is that site that has like over 600 number theory problems. They lend themselves to being solved with computer programming, you know, all different languages, but we're using Python. So what I do is I go to the archives, and as you can see, I have most of them done. No, not the whole 600, most of the first 100. And I go to sum square difference, and we see the problem that we attacked. The sum of the squares of the first 10 numbers, the square of the sum of the first 10 numbers, and then you find their difference, and then Euler asks you for that particular algorithm to be run on the first 100, and you get the answer down there, okay? We took that, and we created some code here where we created a variable called limit, which went to the end, and it was 100, so we're going to go back and make it 10, so it does that first example. And SOS is sum of the square. So we hopped into a loop and went from 1 to 10, and we calculate the square of the sums. So what we did was we squared the number, and then we added to an accumulator, and then at the end we print it. Okay. Then we do the square of the sum, not the sum of the squares, and we jump into that same loop 1 to 10, and this time we just add up the numbers, but this time when we come out we square it, so we get the square of the sum. So if you run this, all right, now we get our little work area going so we can see what we're doing. And you can see we get 2440, and that, as you can see up here, is the answer to the worked example. So then all you would do is you go and change your limit from 10 to 100, rerun, and you would get 251-64150. And if you go back and you look at Project Euler, that's the answer. Okay? But when I look at this code, and it's simple, and we were doing loops and simple variables at the time, but when I look at that code, I think to myself, we could probably do that a little differently and a little more efficiently. So what I'm going to do is I'm going to say save as, and I'm going to go to Python Data Science, class. Now, first I want to go to summer. Then I'll go to, do I want to go to class 2? Why don't I grab a new folder? I'll call it Euler with funcs. And I'll go there, and I'll say Euler with funcs is good enough. Right there. So I'll rename it. Rewriting 6 with functions. Okay. So why am I there? I'm tired because I was up late last night, because for the first time, and I've been out of it for a little while, granted, because I've been moving, I discovered that the Ken Burns Vietnam documentaries are on Netflix. Now, I was watching them free on PMDS when they were coming out, but I got taken away from that, and I only watched up to like number 5. I only got like almost to 10, and then now I can start watching the rest of them. Now I can see the other 5 because they're on Netflix. I was about to say they're free, but you pay for Netflix. But, you know, when something comes up on Netflix, it feels like it's free. But I was watching some of them last night, and all of a sudden the time got to me, and it was 2 o'clock. So, again, I digress. So now, I'm still going to leave that up there. But I look at this problem, and when I see Euler, I think it's 3 different problems. First, I want to get the sum of the squares. Then I want to get the square of the sum. Then I want to get the difference. So in my programmer brain, I see 3 different problems. The first problem, the sum of the square, to me, should be compartmentalized in a way and have its own little function. So let's forget limit for the time being. And what if we put it in a function? So let's say def, and we'll call it SOS, and we'll take a parameter called n, and that'll be our limit, okay? And then we can do all of this stuff. I don't have to set that because, well, yeah, actually I do have to set that. and I can still call it SOS. So now instead of limit, we'll do n. We'll go through that loop. Actually, we want that there. And I'll print it for the time being, but let's get this code out of the way so it doesn't hurt us. All right, boom, 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 boom. So I'm going to say print SOS 10 and see what we get when we run this. 385 none. Why did it print second time? Why is that? Oh, because it doesn't have a return. So I don't want to print SOS. I want to return SOS. There we go. So now when I give it 10, it does that logic and functionality in a function. Sets that variable to 0. Then it jumps into a loop from 1 to 10. Does my calculation just like it did when we did the loop. And this time when it's done, it returns that value. So it figures it out and then returns that value. So if I do it for 10, it's that. If I do it for 100, it's that. Okay? So we'll figure that out later. Now we want to do the same thing with square the sum. So let's do it. I'll say def square of sum, and I'll say n. And I'll say square of sum equals 0. And then I will say for that equals that, and then I will do that, and then I want to break out and do that, and then instead of print, I want to return, not retrun. I do that all the time. All right. So now I have two functions. And let's print. We'll do SOS 10, and then comma square sum 10. Uh-oh, something's wrong. Doom, 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 doom. Limit, I didn't change my n. Okay, all right, so we get 385 and 3025. These are familiar numbers. Okay, so now basically if I wanted to solve the problem, I would say print the difference is, and that quote, and I would do square of sum 10 minus SOS 10. And you know we're going to change this. So I'll do that. Why didn't that stop? Do I need another print? Alright, so now when we run it, alright, the difference is 2640, which is the correct answer. So now, if we go to all our spaces, and you know this is making me crazy, we're going to change it, then we get the correct answer. So basically what we've done, and I'm going to get rid of this line because we don't need it, and I'm going to say limit equals 10. So I am going to use that limit variable after all. And we're still good. Okay? So now we've rewritten Euler 6, but we've taken those different tasks, that compartmentality, and we've taken it and made one function that does one thing, another function that does the other thing, and then in the final line for the difference, we just use the functions. Okay? Now, I could make it interactive so I could ask for the limit. I'm not going to do that. You can just change it right here in this one spot, and when you rerun it, you'll get the different numbers, and it'll give you the difference, which is all it wants at the end. It just says find the difference, okay? But there's one more little thing we can do. Watch this. I'm going to say new file. All right? And I'm going to call it my Euler library. And what am I going to do with my Euler library? First, I'm going to save it. All right, I'm in the right spot. So I'll call it Euler lib. I'm going to come here. And I'm going to grab these things. I'm going to copy. Oh boy, it's always scary when you do that. But I think I'm going to be okay. And now I paste it in here. Okay. So I save that. And I do that. So now, what do I want to do? If you watch the third video, you'll see all I want to do is say import Euler. And you're like, whoa, wait a minute. That's not math or statistics or the standard library. That's something you just made up. And my answer to that is yes, you're damn right. You can create any module you want. All you have to do is have defined functions in there. I'm going to import from that library, and I'm going to use it here in my program. Now, doing what we talked about in that third video, I am going to say eulerlib.sqos, and I'll go back and do it the other way. And that. So now, little definition, 1, 2, 3 lines, I'm still fine. Okay? I'm still running that program because I import from the Euler lib. And the Euler lib has got my code right there. So now I can take Euler lib and just put it off to the side. And anytime I write a program, I can import it and use that code. Got that whole square of sum and sum of square thing licked. Never have to do it again because I've written the code. I've put it off to the side. That speaks to something we try to do in computer programming called code reuse. When we code something, we don't want to have to code the same thing up again. I don't want 2 weeks to have something like this come up and have to sit and rewrite the square sum stuff. Put it in a library. Keep it for later. You will see. You'll have your own library. Probably have your name on it. When I was a kid, it was larslib. And all the utilities you like, all the code that you've written, all the logic that you have that does things for your programs and your code, you'll have it. You'll have it in a lot. Mine was a C library, but it's the same concept. Okay, so we took that logic and we created functions with it, and now we've taken those functions and put it in our own library. Now, the reason I'm able to import like that is because the first place that, and I'm not going to belie an extra credit question, but the first place that Python looks for a library is in the home directory, the directory of the program. Then the next place it looks is a place called your path, which is about predefined directories in a variable name, usually on your Windows system or your Linux system, even with Mac. Mac is mostly Linux nowadays, if you guys don't know. And basically, there's a certain directories in your path that it'll look for. Then the third place it looks for is the library directory, the place that we looked at in video 3. Okay? So if you have something sitting in your home directory, it'll override what's in the library, which is why if something doesn't work, read your slides. All right? So I have this in the same library. Now, one more thing we could do if we wanted to, and I don't know why I would show you this because I told you not to do it, from eulerlib import sos, sqos. So now if I did this, you won't need to put eulerlib in front, and you can just do that. So now when we rerun, we're still good. Okay, we can do that for 100. All right, still pretty quick. 1,000. Wow, pretty quick. Still pretty quick. Look at the size of that number. That's crazy. All right, that one took half a second. But look at the size of that number. Goodness gracious. What is that, 100,000? Yeah, okay. Let's see what a million does. Okay, that took a time. Did you see that? That was a hard beat. That was about second and a half. Okay, when you give it a million. But that's the power of programming and using computers to solve problems. We broke down our problem into a discrete set. So now, just as easily as we did 10, we just did a million. Okay? And we still found the answer. So that's the power. When you create these solutions and you create this code, you create that general solution so that you're not just doing the simple example you want. Then you can do anything you want. Any example you want because you have a general solution of the problem, okay? All right. I will take Euler with functions and I'll throw it up in Sakai. Keep your eyes out because in the next couple of days, first of all, tonight, it's Tuesday, the 26th. Tonight, you're going to get the assignments. And then a couple of days down the road, I don't want to hit it for you right away because I want you to try it yourself. But maybe around when the weekend hits, Friday-ish, I'll do that video where I do my own little homework assignment. You'll see it's fun. We look for palindromes in a big file full of numbers. And it's fun and it's easy and it's eerily similar to your homework assignment. So you can see somebody going through a similar process. All right? All right, not even 9 o'clock and the video is over. That is excellent because now I don't have to worry about it later. All day long I'd be like, oh, I got to do the video. I can't fall behind. Now it's done. All right, enjoy your day. I will get back to you later in the week, and I will definitely do an announcement tonight and release the assignments for Unit 3. All right? All right, then you be good. I'll talk to you later. Bye.